Hello viewers, welcome to C Systems Private Limited. We are the original equipment manufacturers for water leak detection system and other products for the critical rooms like data center, server rooms and critical facilities. What is the use of water leak detection system? All the critical rooms like data center and server rooms have a raised floor. And the rooms are all unmanned. When there is a possibility of water being flooded below the raised floor due to the leakage in the pipelines of chill water pipelines and other sources where there is a possibility of water leak, this will create a downtime to the entire data center and causes huge damage to the service providers. So this water leak detection system is installed in the critical rooms. You can see the water leak detection system in the display. I've shown it. It has basically got three parameters, three sessions. One is the master panel, and the other one is the module, and the third one is the sensor cable. So our master panel is AWLD2400, or model number is AWLD2400, and module is AWLD M32. Master panel and module is connected through two core 1.5 square mm shielded braided copper cable. The communication between the master and the module will be a 2 core 1.5 square mm cable, daisy chain topology. I will show you the communication termination. You will be able to see a 2 core 1.5 square mm shielded braided copper cable connected from the master panel communication port to the slave modules. From here a 2 core cable is connected and it is connected to the slave module. In the slave module you will be able to see the terminals called D plus and D minus shield. You have to connect it to the D plus D minus shield. From this module to the next module you have a separate terminal called D plus and D minus shield, so that the other modules can be looped together to form a daisy chain topology. In the master panel there is an LCD and the keypad which is for displaying the parameters and programming. We have got 4 programmable relay outputs, 1 fire output, 1 fault output and 1 booter output. These are all the outputs that you can connect to the third party system for integration purpose. Apart from the hardware integration, we have a soft point integration which is connected to the BMS or through our proprietary software which can show the leak detection and location in a graphical format that I will explain to you a little later. This is the SMPS, and there is a provision for the battery. This is a battery compartment. There is a provision for connecting a battery. This is a battery charging circuit as well as an SMPS. You can connect a battery to this so that in case of power failure, the panel will operate in the battery mode also. There is a port which we have provided here. This is for the hooter. We have connected 12 volts hooter comes to here, which will get activated when the alarm is activated. Now we will come to the modules explanation. The module has got inbuilt power supply, which is a 12 volts 3 amps power supply coming up. So we have connected a 12 volt supply directly to this, and the sensor cable is connected to the 4-pin terminal, which will be embedded along with the sensor cable. The communication cable has got a 5-pin connector where D plus D minus is connected to the master panel, and from the other master panel to the next slave we have to connect the D plus and D minus for daisy chain topology. And there is a wiring which we have done for the hooter output. Whenever there is an alarm, the module detects the water leak and locates the location of leak. Also it triggers the hooter locally and in the main panel. Next comes the sensor cable. I have laid a 10 meter sensor cable for demonstration purpose. We have laid it in order to show the location of leak as well as the leak detection. For the demonstration purpose, I have laid it in a zigzag manner. The 10 meter cable is being laid for demonstration. First I am going to configure the SIM module. In our case, there is only one SIM. In practical application, there are multiple SIMs, so which will be cascaded in daisy chain topology. I am just going to configure the SIM module, one SIM module. If you are able to open it, you can see the power being provided to the panel, and you are able to see a display called UER. Sometimes you will get a display called FLT. So the fault or UER means the sensor cable is either not connected or the sensor cable is not programmed yet. So before entering the parameters, make sure the sensor cable is connected and the communication cable is connected to the master panel. Before connecting these two, do not attempt to configure the module. So as you see, we have connected the communication cable between the master and the module, and I am going to connect the sensor cable. Sensor cable comes with a pre-defined, pre-insulated, pre-fabricated 4-pin connector. So after connecting it, press menu, enter. This is ID. I am going to set the length. So press up or down arrow. You have got a menu called le.m. This is the length. In our case, the sensor cable what we have kept for demonstration is 10 meter. So I am going to set 10 meter for the length menu. Press enter. Already it was programmed to 5. I am going to set it to 10. Press and hold the up arrow button so that it raises, and here it is 10. So while setting the length, it should be 1 decimal point. 10 meter means 10.0 we have to set. Do not set 1.0, it should be 10.0. The decimal point 0.0 should be a must. It is a must. So after pressing the enter key, it comes to the length menu. Press exit once. So once the sensor cable is detected by the module, we will be able to see a healthy. So when you remove the connector, you will be able to see a fault indication in the panel. So the moment you connect it, immediately the fault will get to healthy mode. The second parameter is the ID. When you press enter, you will get I.D. I.D is basically the ID to be placed for each SIM module. In our case, the ID starts with 0.1 and ends up to 3.1. So for first ID, you have to keep ID as 0.1. Press enter. Now it is 25.5. It should press as 0.1. 0.1 is the ID for first module. Similarly, for the second module, it should be 0.2. For third module, it should be 0.3. And for 9th module, it will be 0.9. And for 10th module, it will be 1.0. So in very simple sense, ignore the point while setting the ID. That is a simple point to be noted. So press up arrow and down arrow to set the required IDs. The only criteria is for first ID you have to keep 0.1, for second ID you have to keep 0.2. And there is one more information I would like to share is press update it and you will get a display called ID. After this enter is pressed, you can press exit so that the healthy will be placed. The other limitation is during the addressing, the module should be addressed in such a way that it should start from 0.1 and there should not be any missing of IDs in between the SIMs. Suppose we cannot keep a configuration like 0.1, 0.2, 0.3, leaving 0.4, the next module cannot be 0.5. So it should be a continuous, it should be a discrete numbering should be there. So from first ID to the consecutive ID, the ID should be kept as 0.1, 0.2, 0.3. We cannot miss as an ID in between the two IDs. This will lead to indication of fault in the master panel. So after the modules are being configured, we are going to configure the master. In the master panel, you will be able to see the display systems for water leak detection system and site name. Press menu, enter and menu is there. Press menu, you will be able to see 4 parameters: test menu, fault and history. The test menu is used to test the module status in the bus. How many modules are there and what are the status of the each module. We'll go to menu, press M. The first line is destination, where we can set the site name, module name, and we can reset the name. So site name can be typed with the alphanumerical words, where we can select it through the keypad and press. When you press exit, enter, you will get saved. In our case, I am just exiting it. So second menu is module name. In this module name, we can set the name of each module. We can identify it through the room name or the location name. And if you press enter, you will be able to edit that room name, and there is a provision to select the relay, programmable relay for the particular module. For example, SIM module 1 is programmed for relay 1. So whenever there is an alarm from SIM module 1, the relay 1 will get activated. We can select from relay 1 to relay 4 based on the requirement. There are totally 4 programmable relays. We can group the relays based on the requirement. So once it is saved, we can press enter to get saved. I am just exiting out for further menu. And 3 is the reset time, just to reset the name of the existing system. And second is parameters, date and time, and slave ID, device ID. This device ID is nothing but the master panel will have an ID in order to communicate to the BMS. For that, we have provided the device ID. And point number 3 is clear history. This will clear the entire history of the alarm indications and whatever is the fault or service information. All the event histories will be cleared when you press the third option. Now I am going to the third menu, that is module quantity. Here module quantities are mentioned. So we can, a master panel can accept up to 32 modules in a bus. So how many modules we are going to install inside, that many modules we have to input in the modules quantity. The maximum is 32, and in our case we have only one module, so we have set it as 0, 1. If you have this is 0, 1, and I just press enter, successfully updated. So the communication is happening between master and the module. So you will be able to see the communication getting happen between the 2 LEDs blinking. This LED is basically, these 2 LEDs is the communication indication between the master and the module, and these 2 indication is between the communication from the master to the third party software or the BMS software. What you are able to see is the BMS application or the software that we provide, our proprietary software for water leak detection system with location in the map view. Either this can be used or it can be connected to the third party BMS system. I will just show you I have shown you the screen. I will just show you the connectivity, how it is being connected, and the hardware part also. From the master panel, we are running a 2 core 1.5 square mm cable. This is connected to a converter, which is basically an RS232 485 converter. This converter is connected to a gateway called Green Tree Frameworks. This is our own make. We are the manufacturers for this, and the hardware and software is manufactured by C Systems Private Limited. So this basically collects the information, and you will be able to pop it out in the graphical screen with the floor plan loaded in the screen. You will be able to see the floor plan of the system with the sensor cable being connected in this.